This is number 2 on the 2024 AP Calc BC exam, number 2 on the free response question set. This is actually quite calculator heavy. So you got to punch things in smartly. Okay, so number 2 says a particle moving along a curve in the xy plane has position x of t, y of t at time t seconds, where x of t and y of t are measured in centimeters. It is known that x prime is this, y prime is this. At time t equals 2 seconds, the particle is at the point 3, 6. Find the speed of the particle at time t equals 2 seconds. Show the setup for your calculations. Speed is the magnitude of the velocity vector. So this is the position vector. Velocity vector is x prime of t, y prime of t. Magnitude is x prime of t squared plus y prime of t squared. So we want speed at t equals 2. So that's why I wrote speed is equal to square root of x prime of 2 squared plus y prime of 2 squared. X prime of 2 is 12, so plug in t equals 2 into here. Let me actually put the laser on. Oh, should be this one. Okay. Plug in t equals 2 into x prime here. You get 12. Plug in t equals 2 into y prime here. You should get this guy. Store it as a number in your calculator. So I just wrote the exact answer here for illustration. Therefore, speed is this number squared plus this number squared under the square root. So it's 12.304, something like that. Don't forget your units, centimeter per second. Okay. So then, next one. Give me a second. I always have trouble navigating. Okay. Find the total distance traveled by the particle over the time interval t is between 0 and 2. Show the setup for your calculations. So to find the total distance, we can just find the arc length, right? Because if you measure the length of the arc, that's exactly how much this particle traveled. Okay, so the arc length formula is this. You're going to go from 0 to 2, x prime of t squared plus y prime of t squared. So plug this as like y1, plug this as y2, and then you can do like f int square root of y1 squared plus y2 squared under the square root. And if you plugged it incorrectly, you should get 15.9017. And then don't forget units again. It is in centimeters. Find the y-coordinate of the position of the particle at time t equals 0. Show the setup for your calculations. So the y-coordinate, well, they give us this initial condition. So we got to use it somehow. So let's use a definite interval. Integral from 0 to 2, y prime of t dt. We use the fundamental theorem of calculus that tells us it's y of 2 minus y of 0. So this left-hand side, you can plug into your calculator. You should get 7.17361, something like that. Store it as a variable in your calculator. Don't round. Like I just rounded here to show my work, but you should put some of that on your papers to show your work. Again, I don't have the scoring guidelines, so I'm just writing out as much as I can. So, and keep as many digits as possible. Okay, so left-hand side, put it in your calculator, you should get this, equals y of 2, they give that to us, at t equals 2, y equals 6. So that goes here. And then we solve for y of 0. So y of 0 should be minus 1.17361. Okay, I don't think you need units here because they ask for y coordinate. Okay. And then lastly, for t between 2 to 8, the particle remains in the first quadrant. Find all times t in the interval t is between 2 to 8 when the particle is moving toward the x-axis. Give a reason for your answer. So this is in the first quadrant. You can just imagine when the particle moves toward the x-axis, the height or the y-coordinate is getting less and less. It's moving toward the line y equals 0. So that means, as I just said, it's getting less and less, meaning it's decreasing. So y prime, the derivative, is less than 0 because the function is decreasing. The derivative is negative. All right, so we just got to find where this guy is negative. You should graph it. Okay, so I didn't show the graph here, but you can see where it crosses 0 between 2 to 8. T is 2 to 8. You can see that it crosses 0 at this number 5.22183. And you can clearly see when you graph it that after that, the function is negative. This y prime is negative. So between 5.22183 to 8, it's moving toward the x-axis. So I don't know how picky they are on if you should include this point, because right here at 5.22183, it's not moving in the y direction because the derivative is 0. Y prime is 0. So I would not include it, technically, if I'm being picky. Okay, so I would not include it, but you can clearly see at the endpoint, the derivative is negative. So it's clearly moving toward the x-axis because it tells us that it remains in the first quadrant the whole time. So you can assume that since it's still moving toward the x-axis, then, or since the derivative is negative, it's still moving toward the x-axis. Okay, so I maybe should say that maybe let me reword it a little bit. I would say like find all times t, the particle is moving toward the x-axis between 5.22183 seconds and 8 seconds, something like that maybe. I don't know if this is needed to say, but in the context of this problem and to give units, I will just put that. Okay, and that's it for this problem. So not too bad. You just got to be very careful as you punch things into your calculator.